length of 20 centimeters, what is the length of FK to the nearest whole centimeter? Okay, so we want to know IK has a length of 20, so we've got this is 20 centimeters. We want to know FK, which is that one. So what we're going to do is we're going to use this information here from this triangle to work on this triangle. So I'm just going to go ahead and draw the two triangles over again. F, I, K. And this is F, H, G. This is 17 degrees. This is 4 centimeters, 3 centimeters, 5 centimeters. This is 17 degrees. This is 20 centimeters. Okay, so I want to know this one. Well, I have this one. I know this one. The one I want to know is FK, which is this one. So I'll put an X right there. So what I'm working with, now let's label this here. This is 17 degrees, so this is the angle. We're gonna use this as our reference angle. And this is 90 degrees, so this here up here is the hypotenuse. And this one is adjacent. And this one is, of course, the opposite of this angle. And this one doesn't matter because I'm not going to work with it. I don't know what it is and I don't need it. So I'm going to work with the opposite and the hypotenuse. And that means I consult the Great SOHCAHTOA. According to the Great SOHCAHTOA, opposite and hypotenuse is here, opposite and hypotenuse. So I'm going to use this. That's the sine of 17 degrees is equal to the opposite over the hypotenuse. And I know that the sine of 17 degrees is equal to, this is 20, and that's 20 centimeters. I'm not going to worry about the centimeters, we'll just add it at the end. And the hypotenuse is the one I'm looking for. I don't know what it is. I'm going to write down X. Okay, and that is for the red triangle. Now let's look at the green triangle. We're going to use whatever we have here, we're going to use again for the green triangle. Okay, so it's the same thing. The sine of 17 degrees is equal to the opposite over the hypotenuse. So the sine of 17 degrees is equal to the opposite. So let's label here what we have. Here's my angle. This is my 90-degree angle. So across from the 90-degree angle is the hypotenuse. And then one side of my angle is hypotenuse, the other side is adjacent. So this is adjacent. And across from here is the opposite. And again, I'm sticking to opposite and hypotenuse, so I'm not even going to worry about that. The opposite here is 3 centimeters, and the hypotenuse is 5 centimeters. Okay. Since I did the opposite and the hypotenuse of these, and these are similar triangles, they have the same angles, that means that when I divide these, it should be the same as when I divide these, which is what the sine of 17 degrees represents. So then I can just take this, should be equal to that. So I'm just going to rewrite that. 20 over x should be equal to 3 over 5. This should equal this because these are the same. Okay. So I'm going to solve for x. So first thing I'm going to do is multiply by x on both sides. Multiplying by x and dividing by x, they cancel each other out. So I get 20 equals. And the x is a whole number, so it gets multiplied by the numerator. So that's x times 3, that's 3x. And keeps it at 5. Now I'm going to multiply by 5 times 5 here. 5 times 2 is 10, plus the 0 is 100. Again, multiplying by 5, dividing by 5, they undo each other. 3x times 1 is 3x. And now here, finally to get the x by itself, I'm going to divide by 3, because that's the opposite of multiplying by 3. Divide by 3. I get x equals, and that's going to be 33.1/3, or not point, 33 1/3, or 33.3. And so we write our final answer. X, which is this side, which is FK. FK, segment FK measures 33.3, and these are all centimeters, so it's centimeters.